Good morning.
Good morning, everyone.
Good morning.
I hope we are all doing well. Okay. So, okay. Um, all right. So, Auntie Love, Auntie Love.
Yeah, good morning.
Yeah, I hope you are doing well.
By the grace of God.
I'm good. I want to start with you. Will you like to borrow money to someone? Like you are borrowing 20,000 to the person, and you would like to take the 20,000 in 2 years again. You are borrowing 20,000 to the person today, and you would like to take the 20,000 in 2 years time again.
No, please.
Why?
Because 20,000 now, the value of 20,000 now will not be the same as the value of 20,000 in 2 years to come. What 20,000 can buy today cannot buy the same thing next 2 years.
So what do you think will make 20,000 to buy something today, but 20,000 will not buy the same thing in 2 years time? What do you think is going to make that particular thing possible?
What do I think I can use 20,000 to buy today? Oh, I
I'm
didn't get
saying
the
that
question.
what do you think will make 20,000? What 20,000 will buy today? What do you think will make 20,000 not to buy the same thing in 2 years time?
Inflation can cause that.
Inflation can cause that, isn't it? Okay.
Exchange rate.
The exchange rate can also cause that. Okay. That means that we know what we are coming to do.
No.
All right. So assuming someone wants to buy you, like someone say that, oh, in 2 years time I'll buy you iPhone. What question are you going to ask the person? Or what are you going to tell the person? Oh, I'll buy you iPhone in 2 years time.
Then
What
the current iPhone in the 2 years comes, what I want.
what concern are you going to raise based on this issue? I'll buy you iPhone in 2 years time. What concern are you going to raise about this particular issue?
There's a risk that the person might not even buy the iPhone in 2 years' time. You can
That,
die or
so what are you going to prefer? Like if the person say, oh, I'll buy you iPhone in 2 years time, what are you going to say that you prefer?
I want it now.
Exactly. That's what I want to hear. You are going to object that, oh, you should buy if you buy me the iPhone right now, it will be better. You will say you want it now. Are you okay? All right. So that should also indicate that maybe there will be a time value of money because you don't know whether the person will be there or not. So the risks and then the uncertainty is also there because you don't know whether the person is going to be alive or something. And also, you also prefer immediate consumption to a deferred consumption. Oh, in 2 years' time, I will take you to Dubai. You say, oh, take me now. I would like you to take me now because you prefer immediate consumption than a deferred consumption. So all that we are saying right now is an indication of what time value of money. What do you mean by time value of money? What do you mean by time value of money? Value of money is defined based on the quantity of goods that money can afford. So we are saying that value of money is defined based on the number of units that a certain amount of money can afford. That's what we say value of money. So if 10 cedi can afford 10 bags of orange, then the 10 bags of orange is defining the value of what? The 10 cedi. So value of money is defined based on the quantity of commodity or quantity of goods that amount of money can afford. So if 10 cedi can buy 2 tomatoes. It means that the 2 tomatoes is the value of the 10 cedi. The value of money is defined based on the quantity or the amount of commodity or goods that that amount of money can afford. That is what we call the value of money. But now we are adding time. We are adding time. So let's assume that today is Sunday, that 10 cedi can buy 2 tomatoes. It is likely possible that next Sunday, that 10 cedi cannot afford the same 2 tomatoes again. So if we are saying time value of money, we are saying that what money can buy today, it is likely possible, it is highly possible that that amount of money cannot afford the same quantity in the future. That's why we are saying time value of money. And the time value of money is based on the principle a bird in hand is better than what? A bird in hand is better than what?
A bird in the bush.
It's not really a bird. It's higher than 10 million bird that is in the bush. If you have one cedi, if you have one cedi in your hand, you know that it's one cedi that you have. But if someone is promising you 10 million, you are going to value the one cedi that you have than what? The 10 million, because you don't know whether you are going to get a 10 million or the person is lying to you. So what you have in your hand today is better than what you are yet to have. That is the time value of money is based on that particular principle. And all that we have said right now is an indication of time value of money. So they can ask you, what are the factors that influence time value of money? Or what are the determinants of time value of money? The first one, the foremost, is inflation. The first factor that determines time value of money or that influence time value of money is inflation. What is an inflation? If they say inflation, what is the meaning? What is the meaning?
The rampant increase in goods and services.
The rampant increase in what?
Goods and services.
Okay, inflation. We always talk about the price. Okay, so it will be the rampant increase in the price of goods and services, or goods or services. Okay, so what we are saying is that if you have 20 cedi today, and that 20 cedi can buy maybe 2 pence, so it means that 1 pen is what? If 20 cedi can buy 2 pence, it means that what? 1 pen is what?
10 cedis.
10 cedi. Okay, now they have increased the price to 12 cedi, and you have the same 10 cedi. Can you use it to buy the 2 pence again?
No.
Because of what?
Inflation. The price has been increased.
Okay, so that is the inflation. So what a certain amount of money can afford today, that same amount of money cannot afford the same amount of commodity again, because the price will increase. That is the first one. But anything that we are going to say, inflation is the first factor. All the remaining factors are out of inflation, but you write there. So the first factor is inflation. The next one is investment opportunities. Investment opportunities will also indicate time value of money. Okay. Assuming, okay, Auntie Joyce, I will use you as an example. Okay. Because you are the only business person among us here. So if the rest are claiming that they are business persons, I don't know of them, so they should tell me. Okay. So
Yes, I'm a business person. I do Momo.
okay. But what I want to talk about right now, okay, you do Momo, so I'll use you two as an example, but I want to use Auntie Joycelyn as an example first. Ladies first. Okay. So Auntie Joycelyn,
Yes.
right now you are there, and a customer comes to you that she wants 10,000 years of 10,000 years of maybe a certain cloth or something, okay? But you don't have the resources to get this,
Mhm.
You don't have the resources to get the 10,000 years. You don't have the resources to get the 10,000 years. What will be your reaction to this?
If I don't have the resource,
Mhm.
mm, I'll either seek to borrow from a bank or something like that to be able to
It's not that you either. You try every ways and means to get the
get
resources
the
to do this.
to get the fabric to deliver.
Okay. Why will you try every means and ways to do that?
Um, because I don't want to disappoint my
It's not
customer.
forget about the disappointment. The person is saying that, oh, if you can't get it, don't worry.
For my gain too, because I'll get some interest on it.
You get some profit on it, which you are not
Yeah.
even you are not even sure that maybe tomorrow or you get this particular opportunity again.
Yes.
You get this particular opportunity again. Okay. So what we are talking about investment opportunity right now is that okay, there is an opportunity where you can okay, let's see that this one yard you are going to be getting 20 cedis on it. You are going to be getting 20 cedis on it. If you should be able to supply this, you get 20 cedis on 1 yard. And the person
Mhm.
wants 10,000 yards. You see that you are going to prefer having the money today to supply this than maybe having the money maybe next week to supply this
Yes.
because of the gain that you are going to get. Maybe next week, maybe this one will not also be there. Or you just prefer, let me get the money today because maybe next week I don't even know whether the demand will come again. So investment opportunities, you have 1,000 years, you prefer to have the money and produce the 1,000 years for the person and get a profit than you producing that particular 10,000 years maybe in a year, in a month's time or something. So sometimes the gain that we are going to get from the investment opportunity, we always prefer to have it today than to take it maybe in the future time because that particular gain might not be the same again. That is an investment opportunity. The next one is immediate consumption. People prefer immediate consumption to a deferred consumption. So immediate consumption, immediate, immediate consumption. Okay. Someone is saying that I'll buy you an iPhone in 2 years' time. You will tell the person that you want the iPhone now. Someone is saying that he will take you to KFC Christmas time. You will say that, oh, you want it now because the 1 year time, you don't know whether the KFC matter will come on again. So you want to enjoy now and leave it. What will happen tomorrow will happen. So our desire for immediate consumption also indicate time value of money. If you should say that, okay, I want the iPhone now, then maybe in the future, it is telling us that maybe the value of that particular iPhone that you want now, maybe the value might not be the same. The time that iPhone 11 was out, you see, we are all going for it. We are all going for it. But right now, nobody is going to go for iPhone 11 again. 14 is there, 13 is there. So that also indicates time value of money. The next one before we move on to is risks and uncertainty. Risks and what? Uncertainty. Okay. Risk and uncertainty. All right. Okay. if if you are a producer, they are giving you 1,000 customers today, 1,000 customers today, and they say, okay, 1,005 customers in 1 year's time. Which of these are you going to prefer? They say they will give you 1,000 customers today, or they will give you 1,500 customers in 1 year time. Which of them are you going to accept?
1,000 customers a day.
1,000 customers today. Why?
Because I want them now.
Uh, okay. Is that Robert? Is that Robert? Oh,
Oh, that's
No,
Idris.
please.
okay, Robert. For you, what
Yes,
are you
sir.
going to pick? 1,000 customers today. 1,000 customers should come to your joint, or 1,005 should come 1 year time.
Say I want 1,000 customers today.
Why?
Say in 1 year time, the uncertainty, there's the risk of uncertainty whether even that 1,000 customers will happen in that, and also, as you said, there are inflation and other factors may also affect the spending of the people in the near future. So we don't know. The uncertainty surrounding the future is higher than what you know now. So it's better I take what I have today than to risk the inflation and also the possibility that the people may not even have the funds to even spend around that time.
Okay, I will leave inflation out of this. I will take the possibility that the people might not have the money to spend at that time. Okay, I will take
Okay.
that particular one. Okay, the future is not certain. Even earthquake or natural disaster can happen and we are all gone. How do you get 1,005 customers? You see, so because of the uncertainty, like we don't know what is going to happen tomorrow. So if you give me 1,000 customers today, I will like it, because I don't know whether I will be alive to even see the 1,005 customers. We don't know even if the world will exist again, these 1,005 customers will be in it. And we don't even know whether these 1,005 customers are going to have the ability to come and buy what they should have bought today. That is the uncertainty. The future is not certain. The future is not certain. But the risk has to do with you having information about a gain or a loss happening. So for the risk, you have a certain information about a thing. There's a possibility of a gain. There's a possibility of what? A loss. There's a possibility of a gain and there's a possibility of a loss. Uncertainty means that you have zero knowledge about a thing. But the risk is talking about you having a certain knowledge about the thing, whether the thing is going to, whether the thing can be a gain or it can be a loss. So the possibility that maybe only 30% of these people can be able to afford what I'm selling today in the 1 year time. But uncertainty has to do with you don't even know whether these people will exist or not, because you don't have any information. But if you have information that only 50% of these people over the past, only 50% of people who are able to afford your commodity today, only 50% will be able to afford it in the future again. So with this one, you have the risk, or they are saying that there's a possibility that everyone will come. What if everyone or all the people doesn't come? What will happen? That is about the risk. But uncertainty has to do with you having a zero knowledge about what is going to happen. So that means it can be earthquake. You don't know what will happen. We all die. Or the people might not have the resources. But if there is a chance that, okay, this number of people will come, that is the risk. It is not possible that all the 1,005 people will come. Maybe some will come, some will not come. And that is the risk. That is the risk. So the risk of you not getting customers up to the 1,005 in the future is you preferring the 1,000 today, because the 1,000 you're not going to do anything. The people are there. You just sell to them. But there's a risk that all these 1,005 people will not come, and maybe less than 1,000 will be there, and you'll be losing. That is about the risk. It is for this idea of time value of money. That is why if you go to the bank and borrow money, they normally charge what? Interest. Because they know that if they are giving you 2,000 Ghana cedis today, what these 2,000 Ghana cedis can buy today, in the 5 years time that you want to finish paying, the 2,000 Ghana cedis cannot buy the same thing. So what do? We now have to estimate the value of the 2,000 in 5 years time, what the 2,000 can buy. Or if 2,000 is buying 10 bags of cement today, and you came for the 2,000, we just have to estimate the value of the 10 bags in 5 years time, and we ask you to pay that particular amount. We ask you to pay that particular amount. That is the time value of money. So if
Sir,
yes,
please, I have a question, but it seems I'm jumping the gun. But per the discussion that we have had so far, it seems that the short term or the early acceptance or taking of offers seems to favor or stands to have a better advantage than maybe taking the option later in a later date.
Yeah.
I want to find out, does it suggest that in our calculation or in calculation we will get other element that will help us know the decision at the future date? So therefore, it does not necessarily mean that always the short term favors is more favorable than the waiting and then taking a decision maybe some other time.
Okay. The decision, whether you should take the decision in a future time or not, will tell you the interest. If there is no interest, if the person is not going to pay interest on the money that the person is going to take from you, then there is no need for you to lend the money to the person and get the same value in the future time. So what will ginger you, what will motivate you to lend is the interest. So if the person has accepted to pay interest on whatever amount of money that you are going to give to the person, then you can be motivated to give out. Okay, so they're here to give you a question where you advise someone whether the person should invest in this one or the person should do something like that. Are you okay? So
Okay.
what we are coming to look at is simple interest, compound interest, annuity, sinking fund, and loan amortization. If you take loan for the bank, how does the bank calculate the amount that you should be paying, and how did they go about the loan? So those are the things that we are coming to look at. All right. Okay. So I'm saying that it is for this idea of time value of money. That is why if you go to the bank and borrow money, they will charge interest on it. The idea is that if I have 1,600 and one bag of cement is 80 cedis. If I should go to the cement shop right now, how many bags of cement can I buy with 1,600? I have 1,600 now, and one bag of cement is 80 Ghana cedis. If I should go to the bank, if I should go to the cement shop, how many bags of cement can I buy today?
20.
I'll buy 20 bags, isn't it? Okay. Now you are coming to me that you need what? The 1,600. Okay. I know very well that I want to buy cement with the money, and that money, that's if I should buy today, is 20 bags, and then you are now coming for what? 1,600. I will not accept to give you the 1,600 if the money that you are going to give to me in 2 years' time will not enable me to buy the 20 bags of cement. I will not do that. Or what you're going to do is that you will tell the person that, okay, I want to use the money to buy cement, 20 bags of cement, but you want to take the money. It means that in 2 years' time, you have to give me an amount of money that will be equivalent to what? The 20 bags of cement. That is the condition that you are going to give to the person. or you consider whether the person is your friend and say you should give the 1,000 Cedis in the 2 years time. Are you going to do that? Robert, is that what you are going to do? That the person is your friend, so you take the 1,600 in a 2 years time.
Not sure.
Or you, so what are you going to do? If the 1,600 can buy 20 bags of cement and the person wants to take the 1,600, how or what amount of money are you going to be receiving from the person in the 2 years time? Or what condition are you going to attach to the 1,600 that the person is taking from you?
You are going to check the years or the duration the person is going to pay. Then maybe you adjust and see, like you forecast and see whether there will be high prices of goods and services, like inflation or something like that. You consider all those things, and now you consider them now how inflation rate is right now and how it will rise maybe in the few years that the person is going to pay the money. Then maybe you can add that interest to the money.
Okay. Okay. Nice. Okay. What are you going to tell the person before the person before you give the person to the money? What are you going to tell the person? Before you give the person 1,600, what are you going to tell the person? Okay. For me, what I'm going to tell you is that, my brother, this 1,600 I'm giving to you, I want to use it to buy cement, 20 bags of cement. So I can only give you this money if you'll be able to give me 20 bags of cement amount in the 2 years time. Because me, what I want is 20 bags of cement. So if I shouldn't give you this money today, I'm going to buy 20 bags of cement. So since you are going to take it, means that I can't buy the 20 bags of cement today. So what will happen is that in a 2 years time, just give me any amount of money that can afford 20 bags of cement. That's all. So you look to it and calculate your interest yourself. You know the amount that you are going to pay. So in 2 years time, whatever, there's no possibility that the bags of cement, the chance that the bags of cement is going to reduce is very low. Is very low. So the price will always increase. So if you are there, if you are coming to pay me, you will go to the cement shop and ask of the price of cement. Then if they say it's 85 Cedis, then you multiply by 20 and bring the money to me. That's all. That is very simple. So it is for this time value of money. That is why people charge interest, especially the financial institutions. That is why they charge interest on any amount of money that they are giving out. And it is for this time value of money that if people deposit money in the banks pays what? Interest on them. Because if we the depositors, we should decide to go and use that amount of money to buy something, it will be better than putting it in the bank and the same amount of money will be there for maybe 2 years or 3 years. No, it's not giving us anything. So it is for this reason, that is why we charge interest on borrowing, lending, and any other thing. Okay, but how do we charge the interest? We have two ways of charging the interest. Basically, we have two ways of charging this interest. The first one is it can be a simple interest or it can be a compound interest. So we look at the computation of the interest. It can be computed as a compound interest or it can also be computed as what? Simple interest. So simple and compound interest. Simple and compound interest.
Hello, sir.
Yeah.
I just wanted to link the explanation you were giving with the cement to Islamic financing.
Okay.
Where you mentioned those finance want to deal with capital or invest in properties other than cash businesses.
Yeah.
So with the example, 20 bags of cement today, tomorrow can be 800 Ghana cedi.
Yeah.
So for a Muslim or Islam financing, they want you to replace the item back, but not to take money back.
Exactly.
So I just wanted to, it perfectly explains the portion of interest in Islam financing.
Okay.
Because you are not guaranteed what the inflation will be. It can be less or it can be more. So then bring me back the item. It perfectly answers that question.
Thank you, Zina. Thank you, Zina. Since like you have taken a private course in Islamic financing, so these people, the Islamic investors, they are planning to introduce a program called Islamic financing so that people go into it. Well, yes.
Ghana don't survive.
Ghana, there it will not come. It will not come. So it's a very nice, it's a very nice, it's a very nice thing. Islamic financing is a very nice ideology, but just that it will not work in our part of the world. All right. Let's come to simple and compound interest. If we say simple interest, what is the meaning? If we say compound interest, what is the meaning? Simple interest and compound interest. Simple interest.
So
Yes.
simple interest is the additional amount or the fee you pay, for using the investors, the borrowers fund.
Okay.
Mm,
What about a
but
compound
the
interest?
compound one say, unless you help me.
And I don't want to help you.
So that one too will be the fee you pay for using the borrowers fund. But that one, I think it's the fee is charged on both on the principal and the interest. Like, what am I even saying? The principal plus the interest will be added, and then they will find the fee that you have to pay for using the fund.
Okay. Okay. I hope for the compound interest, and you have said something now, so maybe I can give you 3 out of 5 if I can
Okay.
back me your script. Okay. Simple and compound interest. Simple and compound interest. How do we compute the interest under simple and compound interest? Auntie Love.
Simple interest is calculated on the principal amount or the original amount that we took from the person. But
Okay.
with the compound interest, we calculate it on both the principal amount and the accumulated interest over the previous years.
Okay. Okay. That is nice. That is nice. Okay. Auntie Eugenia, you wanted to say something? Auntie Eugenia, you wanted to say something? Okay. Auntie Eugenia, you wanted to say something? Auntie Eugenia, maybe your network is calling you. Okay. For simple interest, the interest is charged or paid on only the original amount taken or the principal amount taken, which the original amount that you have taken or you have deposited is what we call the principal. The interest is charged on only the principal. But for the compound interest, the interest is charged on the principal and the interest itself. So for the compound interest, the assumption is that you are reinvesting the interest. You are reinvesting the interest. But for the simple interest, the assumption is that you choose to deposit or to be taking your interest back. So if you are depositing 2,000 and the interest is 10%, how much will be the interest every year? 10% per annum. How much will be the interest every year? How much will be the interest every year?
200.
200.
Okay.
100.
Okay. All right. You see, this 200, the assumption under simple interest, the assumption is that you go to the bank and withdraw the 200 cedis and keep only the 2,000. That is the assumption under simple interest. So instead of you reinvesting the 200, you go to the bank and take the 200. Then the amount left in the bank will still be what? 2,000. So they will charge the interest on the 2,000. So every year you count for the interest. That is the assumption. Although that is not the case, but that is the assumption under simple interest. But for the compound interest, the assumption is that this 200, okay, you put 2,000 in the bank and the interest on it is 200 Ghana cedis. At the end of the first year, what will be your total amount in the bank?
2,200.
2,200. Okay. So if the bank wants to charge interest, they will now charge the interest on the what? The amount that you have. So under compound interest, the assumption is that you are reinvesting your interest. You are rolling over your interest together with the principal. So you are reinvesting the interest. You are reinvesting the interest. So the interest will be charged on the principal plus the previous year's interest or the accumulated interest for every year. That is the idea about a compound interest. Maybe they can ask you to differentiate between a compound interest and a simple interest. They are expecting you to say something like this. Let's come to the simple interest first. Simple interest is not something that we do, but we can still revise our thoughts on simple interest. Simple interest. Okay, assuming you have deposited 2,000 and every year the interest is 10%. So the interest will be what? 200 cedis every year, isn't it? All right. Assuming you are depositing this amount of money for 3 years. So what will be your interest at the end of the 3 years?
600.
600. How do you get the 600? You multiply by 3, isn't it?
Yes.
Okay. That will give you 600. So at the end of the 3 years, if you are going for the money, how much will you go and take from the bank?
That's the 2,000 plus the 600.
And that will give you
2,600.
2,600. Okay. How did we get the 200? How did we arrive at the 200?
It's 10% on the 2,000.
So 10 over 100 times what? 2,000. So if you want to get it for 3 years, you multiply by what? 3.
3.
So the simple interest for 3 years is calculated like this. Okay. The 10 is what? How do they call the 10? The 10 is the rate, isn't it?
Rates.
Okay.
Yes.
So we can say that rate over what? 100 times the 2,000 is what?
Principal.
Principal amount.
Okay. The 3 is what?
Number of years.
Yes.
Number of years
period.
or time. Okay. So we can now say that our simple interest can be calculated as PRT over what? 100. All of this is over 1 over 1. So we multiply the top and multiply the down. That is a simple interest. We are saying that if we are going for the amount from the bank after the 3 years, the amount that we are going to be taking will be 2,600, which is calculated as the 2,000 plus what? The 600. The 2,000 is what? Is the principal, isn't it? And this one is what? The interest. So the amount can be calculated as principal plus the interest over the period. That is simple interest. Are you okay? But I want to calculate the amount also in a different way. That is under simple interest. We are not going to take any example under simple interest because it's something that will not always come. It's compound interest, annuity, and code that they normally examine. Okay. So our focus will be on compound interest today. If we have some time, we look at effective interest rates, or if we have some time, we can start the annuity, but I will not bother you with the full listing today. We are going to finish on Thursday. So I will not bother you, I will not overload you. But I'll take my time to do the compound interest. If we are able to finish the compound interest early, then we can move on to annuity. Or I'll leave the annuity so that I'll finish everything on Thursday. Okay. All right. So let's come here. I want to calculate the amount straightforward without doing anything. We are saying that the amount is equal to 2,000. The amount is equal to 2,000. Okay, let's calculate the amount in the first year. Okay, so the first year, let me see. Oh, so the first year, the interest will be 10 over 100 times what? 2,000. Am I correct?
Yeah.
Okay, so the amount for the first year will be 2,000 plus what? 200. Are you okay? Okay.
Yeah.
If you go to the bank and take all the 2,000 on percentage basis, how much are you taking? If you go to the bank and take your full amount, which is the 2,000, on percentage basis, how much are you taking? If you give me 2,000,
Please take that again.
okay, if you give me 2,000 and count for the 2,000 on percentage base, how many percentage? Or yes, how many
100%.
you are taking all the
100%.
100%, isn't it? Okay.
Yes.
The 200 represents what? What percentage?
Represent 10% on
10%.
Okay. So if you want to know the amount, it means that you are going to take 110% of the initial amount that you have deposited there, isn't it? Okay.
Yes.
Yeah.
So amount can also be calculated as 1.1 times the 2,000. That will give us 2,200. Are we clear? Okay. This is for simple interest. But a compound interest, we are saying that the interest will be charged on the principal together with the interest. Okay, let's come to, this is simple interest. Let's come to compound interest. Okay, if it should be compound interest, the first year will be the same as the simple interest. Are you okay? So the compound interest for the first year will be 10 over 100 times 2,000 because the interest for that year is 0 at the beginning. So we are not going to have 200 as the interest, isn't it? Okay. In the second year, let's look at the second year for compound interest. How are we going to calculate the interest?
Going
You
to
add
be
It will be 10 over 100 times
100, 2,200.
2,200. Are you okay? And that will give us 220. Okay. Let's now come to how we calculate amount under simple interest. How do we calculate the amount under the simple interest? First year, how are we going to calculate that amount? The first year,
Compound interest or simple interest?
no, compound interest. How do we calculate amounts under the compound interest? Amount. So the first year, the amount will be 2,200, isn't it?
Yeah.
yes.
Okay. Which is the same as 1.1 times the initial amount. Are we okay? All right.
Yes.
Let's come to year, at the end of year 2. The amount will be 2,420. Am I correct?
Yes.
Okay. Which is the same as what? 1 point what? This amount. Are you okay?
Yes.
Okay.
Yes.
Okay. 1 point this amount. Okay, let's come. Let's come to first year. The first year, the amount will be calculated as 1.1 times the initial amount. Are we okay? Okay.
Yeah.
This 1.1 is the 100% plus the interest rate. Then we get what? 2,200. Are you okay? Second year, can we say that second year is the same as 1.1 times 2,000 times 1.1? No, if I'm
I
doing
thought
something, if I'm doing
I thought
something
it
and
would
the
be
thing is
1.2.
if I'm doing something and
I
it's
thought
involving mass, take your time and digest it. Okay. You thought it would be what?
1.1 times 2,200.
And the 2,200 is the same as the 1.1 times the 2,000 here.
Yes. Times 1.1. Yes, true.
Okay.
Can you see that?
Yes.
Yeah.
Okay. Let me come here. Can we say that the 1.1 is the same as 1 plus R? Where the
1
R is
plus
the
R.
rate. Where the R is the rate.
Rate.
Yeah.
Yes. Okay. Yes.
Okay. Can we say that that is the same as 1 plus 0.1? Because the rate is what? Is 10%.
Yes.
Okay. So that will give us 1.1. Okay. Can we say that this is the same as times the principal?
Yes, it's the same.
Okay. Times 1 plus R. Can we say that?
Yes.
Okay. Let's be moving on. Okay. Let me calculate the third year. Let me calculate the third year and see something. Third year, what will be the interest for the third year? Or like actually second 2 years are okay. Let me do that. 2 years is okay. Okay, 2 years is okay. So let's come here. The second year, in the amount for second year can be calculated as 1.1 times 2,200. And that will give us 240. Are we okay? And we are saying that this can also be calculated as okay. We are saying that this can also be calculated as 1.1 times 2,000 times 1.1 because the 1.1 times 2,000 is already the 1,002. Then we now multiply by the 1.1. Okay. I'm saying that if it should be a third year, it means that third year also have to be 1.1 because this is the 2420. So you multiply by 1.1, then you get a third year. So any year that you are doing, you continue increasing the amount by 1.1. Okay. But we can't do that for 20 years. We can't be doing that for 20 years. It will be too long. So let's come with a formula that can be able to enable us to do this. Whenever we have this, what do? Let's just define some letters or alphabet and use it to do this. And I'm saying that the 1.1 can be written as 1 plus R. And the R is the rate. So the rate is 10%. So if this will be 1 plus 0.1, which is 10%, which is 1.1. So we are all good with that one. This amount is the principal or is the today's value that you are putting there, which we can call the present value. Okay. Plus, I say plus, multiply by the 1 plus R again. Okay. If you are doing this, it means that we can say that this is the same as present value times 1 plus R times 1 plus R. Okay, 1 plus R times 1 plus R. What is the meaning of that? S squared is what? What is the meaning of S squared?
S times X.
S times X. Okay. So if we now have 1 plus R times 1 plus R, the meaning is that what? 1 plus R exponent what?
2.
2. Okay. So we can now say present value is equal to 1 plus R exponent what? 2.
2.
We can do that. Okay. The 2 here is representing what?
Number of years.
Number of years. So it is possible that we should use a letter also to define the number of years. So we can now say that if you want to find a future value of any amount under compound interest, just do this. The today's value into bracket 1 plus R, which is the rate exponent n. That is all. That's how we find the future value. So the future value of simple interest is calculated as future value of any amount under simple interest is calculated as present value into bracket 1 plus r exponent n. Okay, this one, we assume that the interest will be compound annually. This is annually compounding. Annually compounding. So let's find this particular one, which the present value is 2,000. The interest rate is 10%, and we are doing it for 2 years. The ends will be 2 years. Let's calculate the future value under that. Let's calculate the future value under that. Okay. So calculating the future value, that will give us 2,000, which is the today's value, into bracket 1 plus 0.1 exponent what? 2. Future value is equal to 2,000 into bracket 1.1 exponent 2. Do this on your calculator and give me the answer.
2420.
2420. Which is the same as what we have gotten if we use the normal way. Okay. Assuming they ask you to find the interest. They ask you to find the interest and the compound interest after 2 years. Find the total interest after the 2 years. How do we do that? What will be the interest that you are paying for the 2 years?
Future value minus the principal amount.
Okay. So it will be interest is equal to future value minus the present what? Value. Which is the same as you are borrowing 2,000, but you are paying 2,420. It means that you are paying interest of what? 420. Okay. This formula is on the assumption that the interest rate is compounded what? Annually. It means that you are paying the interest annually, or you are earning the interest annually. What if the interest is compounded semi-annually? What if the interest is compounded semi-annually? What if the interest is compounded semi-annually? So if you are doing it semi-annually, it means that every year, how many times are you going to pay the interest?
2 times.
2 times. Okay. You are going to pay the interest 2 times. Okay. So semi-annually, the first one that we have done is, okay. So if you are paying the interest 2 times, then at 10%. The first 6 months, how many percent are you going to pay?
You are going to pay
You can decide to use
10% times 2.
No, the 10% is annually. Anytime they give you interest, whether they add per annum or not, it is annual
for a year.
rate. It's
So you
annual
can
rate.
divide it by 2.
Okay. Not that you can divide it by 2. You are going to pay 5% first and pay 5% what?
Yes. Next.
So that at the end of the day, you pay what?
10%.
10%. But in a year, how many times are you going to pay the interest?
2 times.
2 times. So over the 4 years, over the 2 years, how many times are you going to pay the interest?
6, 8, 4.
Okay. It will be 4. Okay. So in this case, if you want to calculate your amount, it will now be calculated as, okay, let me use this one. Let me use the normal way. Let me use the manual way before we come and use the formula. Okay. So let me use the manual way before we come and use. Our present value is what? 2,000. Our interest rate is what? 10%.
10%.
But we are doing this semi-annually. Okay. It means that the first 6 months, the first one will be 5 over what? 100
100.
times what?
2,000.
2,000. Or if you like, you can do 10 over 100 times 2,000 times 6 over 12, isn't it?
Yeah.
The 6 over 12, we assume that it is the interest that you are applying the 6 over 12 on. So just divide the interest by 2, so we are good to go. Okay. So this will give us 100. Am I correct?
Yes.
Okay. So this will give us 100 as the interest. Okay. So 100. So the second interest will be 5 over 100 times what?
2,000.
2,100. No,
100.
2,100. You are doing compound interest.
Yeah.
Okay. So it will be 2,100. So this will give you what? What will be the interest?
105.
105. What will be the total amount at the end?
21.
Was it going to be 2205?
2205. Yeah.
Okay. 2205. Okay. The first one that we did, what was the interest that we paid? It was 200, isn't it?
Yeah.
Yes.
But now the total interest is what? 205.
Um,
What is happening?
we have been
Increase.
charged interest on the interest too.
It has been increased by 5, isn't it?
Yeah.
Yes.
So you can see that the actual interest rate is not 10%.
No.
The actual interest that you are paying now is not 10% anymore.
Yeah. It's more than 10%.
It's more than 10%. And that's what we call effective interest rate. We are coming to look at that particular one. Okay.
Effective what?
Interest rate. But we come and look at it, how we compute it and how we go about it. Okay. But let me focus on the compound interest. Let's now come to our using the formula. Let's find the future value. Okay. Let's now find the future value. The first one is going to be, the first value will be what?
Present value.
1.05 times 2,000. That is the first 6 months. We are doing it semi-annually. So the first one will be 1.05 times the 2,000. Are we okay? That is the first 6 months. What are you going to get? I'm sure you get 2,100.
Yes. 2,100.
Okay. So the next one will be what? If you want to find the amount for the next 6 months, then we multiply this by 1.05 again. Are you okay? Would that give us 2,205?
Yes.
Okay.
That's correct.
Yeah.
Okay. So we can now say that if you want to find your amount for a year, if you are doing it semi-annually, this is the same as 2,000 times 1.05 exponent 2. Are we on the same track? This
Yes.
time, this is okay. So we can now say that future value is equal to 1 plus r exponent what? 2, using the original rate. Are we okay?
Yes.
Okay. Then n times 2 multiplied by the present value. The n over here, we are doing it on annual basis. So the n over there is 1 year. It's 1 year. So we can now say that future value is equal to 1 plus 10 over 2. If you do 10 over 2, what are we getting? It's the
5.
5% that we have used. Okay. Then this will now be 1 times 2. The 1 n over here is always a year times the 2,000. Do it and see what we are going to get. Okay. From this, I can now conclude with semi-annually. So I will now adjust the formula to represent semi-annually. Semi-annually future value is equal to present value 1 plus r over m n times m. Okay. Where the m is the number of times that the interest is compounded. N is equal to the number of times compounding is done. The number of times that compounding is done. Okay. Okay, so let me move on to a different side. Okay, so we are saying that when the interest is not compounded annually, the future value formula will now be present value 1 plus R divided by M. The M is the number of times that the compounding is done, times what? M. Okay. So if we are doing the interest semi-annually for 2 years, so within the 2 years, how many times are we going to do the compounding?
4.
4. So it means that this will now be what? 1 times what? 4. The number of times the compounding will be done. So that will be 1 times 4. If it is going to be done for 3 years, it means that the exponent will now be what? 6. If it is 4 years, the exponent will now be 8. Are you okay? All right.
Yeah.
Let's now come to quarterly compounding. Quarterly compounding. If we are doing quarterly compounding, it means that within a year, how many times are we going to do a compounding?
4.
If we are doing it for 2 years, so the exponent will be what?
8.
8. But in this case, we are going to change the rate now to what? Compounding what? Rate. By dividing the rate by what? Okay, let me count. 10% is annually, isn't it?
Correct.
How many quarters do we have in a year?
4.
So it means that the first interest that will be charged will be 2.5. Am I correct? The
Correct.
first quarter will be 2.5. The next one will be 2.5, making 5. The next quarter will be 2.5, 7.5. And the last quarter will be 2.5, making what? 10%. Let's count to the interest is compounded monthly. If the interest is compounded monthly, what will be let's now change the interest rate to 12. So if the interest is compounded monthly, it means that every month we pay interest of what?
1.
1%. Are you okay? So if you want to pay the interest for a year, how many times are you going to pay the interest?
12 times.
12 times. So if you come here, it means that the interest rate, if it is 12, it will now be 12 divided by what? 12. Then it will now be 1 times what? 1 times 12, because we are going to pay the interest for 12 times within a year. Within a year. But if you want to know the amount for only a month, it means that this will be what? Only 1. Because we want to know the amount for only a month. So that will be only 1. You want to know the amount for only a month, that will be exponent 1. But if you want to know it for the entire year, that is where we are going to have the 12 over here, because we are calculating the amount for 12. Let's take some examples. Then we look at what we are talking about. Okay.
So with what you've said so far,
Yeah.
I think the same question can be rephrased in different forms. Whether you can have it in a month, you can have it in quarter, semi-annually, and yearly. I don't know if you can get in these two.
Yeah, you can get a question, and we are going to get a question that will talk about all of them one by one.
Okay.
So you can have a question that the question will be framed annually, monthly, semi-annually, and all those ones. Okay. Before I'll move on, let me show how we calculate. This one we are calculating future value. Okay, I don't even like I will ask you the difference between future value and present value. Okay, don't worry, we get it. So we are saying that future value is equal to 1 plus exponent n. So right now, if they ask you to find the present value, how do you find the present value?
Do you change of subject?
You do change of what? Subject. So the present value will now be equal to future value over 1 plus r exponent what? N. So if it is monthly or yearly, you still put the m over here times the n over here. Okay, that's how we do it. Let's pick an example. Okay, what do we call present value and what do we call future value? What's the difference between future value and present value?
Oh,
Yeah, the difference between future value and present value?
Future value could be, it's not could be, it's the amount that we have access to now. And present future value will be the amount that we will have to pay if we are having that same money now. How much would it be in a year in the future?
With a
So
simple,
we say
with a rate,
okay.
with an interest rate.
Hmm.
So for the future value, we define it using the interest rate. Okay. How much are you going to pay on a future date with a given amount today? How much are you going to pay on a future date on a given amount today with an interest rate or with a given interest? That is the future value. But the present value is the today's value of the amount that you are going to receive in the future time. Today's value of an amount in the future. That is the present value. So present value, future value is termed as compounding. Whenever you are doing compounding, we say that you are looking for future value. But whenever you are doing discounting, we say that you are looking for what? Present value. So future value is compounding and present value is what? Discounting. So discounting is you looking at today's value of a future value. But the compounding is you looking for the future value of a present value with an applicable interest rate. That is the future value. They are here to ask about future value and the difference between them. So maybe if you have something like that, you can be able to say something about it. Okay, let's take one example or two. I'll come and have time for, oh, shit. Should I talk about this one too? Should I talk about this one too? Okay, let me talk about this one before we move on. Okay, let me talk about this one before we move on. Okay, sometimes the interest rates can be fluctuating. The interest rates can be different every year. So if the first year can be 5%, the second year can be 7%, the third year can be 10%. So you are going to invest the money for 3 years. Let's look at this, how we go about this before we pick a question, then we know that we are coming to solve question on simple compound interest fully. We are coming to solve question on compound interest fully. Okay. Compound interest. Then it means that we can use, we still have about almost 2 hours. Then we can finish this thing today. Let's see. Okay. Let's assume that the amount of money that the principal is 2,000. And this will be invested at a different rate. The first year is 5%. The second year is 7%. And the third year is what? 10%. Let's calculate the interest every year. The first year, what will be the interest? First year. It will be 5/100 times what? 2,000. Are we okay?
Yes.
That will be 100, isn't it? Okay.
Yes.
Let's calculate the amount at the end of the first year. Can we say the amount is 2,100, which can be calculated as 1.01 times 2,000? Can we say something like that?
Yes.
Okay.
We can.
Okay. Let's count the second year. The second year, the interest will be 7/100 times what? 2,100. Am I correct?
Yes.
Yeah.
Okay. That will be how much?
Those will complete.
That will be how much? You can use your phone.
Oh, that will give you 2,247.
It will be 147, isn't it?
No,
147.
That is the interest. But the amount,
Yeah.
the amount will give us
22.
1.05 times 2,000 times 1.07. Can we say that?
Yes.
Okay. The 1.05 is the 2100 times this year, which is 1.07 times the 2100 is the same thing. Let's count to third year. Okay. Third year, it will be 10 over 100 times what? 2247. Am I correct?
Yes.
Okay. The interest will be 224.7. Would that be correct?
Yes.
Absolutely.
Okay. So can we see the amount is the same as 1.05? Okay. 1.07, 1.05 times 1.07 times 1.1, all multiplied by 2000. Can we say that?
Yeah.
Can we say that?
Yes.
Okay. If we can say that, what I want to tell you is that if the interest rate is fluctuating, this is how we do it. The first one, you have 1 plus R, which is exponent 1, the first year, isn't it? Okay. Then this will be exponent 1. If this will be invested for only 1 year, it will be exponent 1. Multiplied by the next rate, which is 1 plus R1, which will also take 1 year. If it is for 3 years, multiplied by 1 plus R2, which will also take 1 year. Now multiplied by the present value. Okay. The R2 and R1 are now depreciating the interest that we are going to use. So I can make this one to be R0, which is the first interest. So if the interest rate is fluctuating, this is how we do it. You can do it separate like the way I have done it and now add them. Or you can now use the formula. Okay, let's pick a question on the compound interest. We move from simple to complex. Let's look at the illustrative question. Let's take that particular question. Suppose you deposited 100,000 Ghana cedis in fixed deposit account for 10 years for a building project. How much will you receive as an interest of 18% if interest is compounding annually, semi-annually, and quarterly? If you come to compound interest, we're just going to put a fixed amount there, and that is the end. We just put a lump sum there, that is the end. But we are going to look at another one that you'll be depositing the money at the end of every year, at the end of every month. That is what we call the compounding. So for compound interest, you go and put the money there, and that is the end. You won't do any, it is not a commitment that you should be putting the money there every year or something. Okay. Let's look at that illustrative example. Then we look at a question now. Okay. So they are saying that suppose what? I hope you can all have access to a question. Suppose you deposited what? 100,000 in a fixed deposit account for 10 years for a project. So the 100,000, is it a present value or a future value?
Present value.
Present value. So we have the present value to be 100,000. Okay. What is the interest rate?
18%.
18%. So the interest rate is 18%. What is the number of years?
10 years.
10 years. Okay. But the question is saying that we should assume that the interest is compounded what? annually. So let's look at the first one. If the interest is compounded annually, future value is equal to present value 1 plus r exponent what? N. So we can now say future value is equal to the 100,000 1 plus 0.18 exponent 10. Are we okay? So we can now say future value is equal to 100,000 1.18 exponent 10. What are you getting?
Five, two, three, eight.
5 to
5, 2, 3, 8, 3.56.
5.56. Okay. No, this is 52 something.
Hey. 5, 2, 3.
523. 523.
383.
38523. The threes are 2 here.
Yeah.
Okay. So 523,383.56. Okay. That is the annually. Let's now come to if interest is compounded what? Semi-annually. If interest is compounded semi-annually. If interest is compounded semi-annually. So let's now come. If interest is compounded semi-annually, future value will be equal to present value 1 plus r over m, n times m. Okay. If the interest is compounded semi-annually, it means that every year the interest will be paid what? 2 times, isn't it?
Yes.
But we are doing this for how many years?
10 years.
So how many times are we going to pay the interest if interest is compounded semi-annually?
20 times.
20 times. So
20 times.
this will be 100,000 into bracket 1 plus 0.09. Am I correct? Exponent 20. Am I correct with the 0.09?
Yes.
Okay. Okay. So this will give us 100,000 1.09 exponent 20.
So the link was very bad, so I lost some part. Please, how did you get the 0.09?
The interest is compounded semi-annually. So, and the interest rate is 20%, 18% per annum. So if interest is paid every 6 months, it means that every 6 months you pay 9%. Are you okay? Are you okay? All right.
Yes, yes.
We are going to pay for 10 years. So if you are paying every year, we are paying 2 times. It means that we are going to pay 20 times for the 10 years. That's why we have the 20 here. Okay. Let's move on. So what are we getting?
560 441.08.
560
441.08.
441.08. Okay. Let's now count to interest is compounded what? Quarterly. If interest is compounded quarterly, what will be our interest rate? What will be our quarter interest rate?
So 4 times 10, 40. 18 divided by 40.
4.5.
0.45.
0.45.
So you get,
So we can see present value is equal to 1 plus r over m, isn't it? and n times n. So you have to find the quarterly rate. So the quarterly rate
Yeah.
will be, so we have 100,000 into bracket 1 plus 0.045. Are we correct?
Yes.
And this will give you 40. Am I correct? Every year we are
Yeah.
paying the interest 4 times. So if you are paying it over 10 years, it means that you are going to pay 40 times. I hope that part is also correct. All right.
Yes.
Okay. Let's move on. 100,000. 100,000 into brackets 1.045 exponent 40. Now, people, compound time value of money questions is something that you need critical understanding to be able to understand what they are saying. Okay, we will get there. Don't worry.
The amount will be 581,636
581,636.45.
0.45.
Okay. Okay. Let's now look at how to find. Let's look at the illustrative example. Another illustrative example there where you have won a contest as the best financial management student. Your price for the contest is 4,500 to be received in 4 years' time. If the current interest rate is 18%, what is the value of your prize in today's term if interest is discounted yearly, semi-annually, quarterly, and monthly? Let's look at that one. And you can see that what the person have won a contest, and the money will be received in how many years' time?
4 years. 4 years.
Okay, so it means that he's going to receive the 4,500 in 4 years' time. He has to wait 4 years' time before he will receive the 4,500. But the question now is, if they should give you the money today, what should have been the value? That is the present value. So we are using the future value to find a present value. We are going to use a future value to find a present value. I'll do one, then you try the rest. Okay. So the future value is given to us. Future value is given to us to be 4,500. The rate is given to us to be 18%, and the end to be 4 years. Okay. I'll do semi-annually, so that you can see that example and do the quarterly and do the monthly and also do the yearly. So we know that future value is calculated as present value 1 plus r exponent n. Okay, for us to find the present value, it will now be equal to future value divided by 1 plus r exponent n. Okay, sometimes they can also ask you to find they can also ask you sometimes to find the value, the number of time or the number of years that it will take you. We are going to look at that. That is also a change of subject. They can also ask you to calculate the rates. That is also a change of subject. We have a one that logarithm and things will come inside. All right. So I'll do semi-annually. I'll do semi-annually. So semi-annually, present value will be equal to the future value is 4,500. Am I correct? Okay. Over 1 plus 0.09 exponent 8. Look at it, the exponent 8. Are you okay with the exponent 8? The duration is 4 years. And we are going to do this semi-annually. So it means that every year is 2 times. So for 4 years will be 8 times. And the interest rate, which is 18%, will now be changed to what? 9% because it's semi-annually. All right. So my present value can now be equal to 4,500 divided by 1.09 exponent 8. Okay. Someone can also do the same thing like this. 1 over 1.09 exponent 8 times 4,500. We don't have any problem with that. Okay. So what will be my present value?
Two to 58 point
2258.40.
40.
Okay. Okay. So let's try that. Let's try that, guys. Before we move on to what we call effective interest rates.
Which pages are the questions on?
Is it?
Which pages are the questions on? The questions.
You don't have it. You don't have the question.
I have the question and I tell value of money, but I don't take the questions.
The second illustrative example.
Okay. On which page, please?
Let me check the page for you. That would be like before the effective annual interest rate. The question before the effective annual.
Okay, you have won a contest. Okay. Okay, now. The first one too is above it. Okay, I've seen it.
Yeah, you have seen it.
Yeah, I've seen the two questions.
Yeah, the first one is 4,500. That's the one that we are solving is 4,500. That is the one that I have solved the semi-annually. I have solved the B.
Okay.
So if you try, actually, if you try the yearly and quarterly, maybe something like that. That would be okay.
You've done for the semi-annually.
Yeah, I've done it for semi-annually, so that maybe you try your hands on the quarterly and the annually. At least
Hello.
Yeah, senior.
Hello.
Senior, I can hear you.
Yes, sir. So are you solving for what are you solving for now?
You are
You're
solving for
going to send
yearly.
me so are you
You are solving
yearly?
for yearly, quarterly, and monthly. This is the one that I've done over
Okay.
here is the semi-annually.
Okay. Okay.
Okay, so I don't know. I have some answers. I don't know whether I can share them now or we have to
Okay.
wait.
Share.
So for the annually or the yearly,
Okay.
I had 3,813.56,
5, 6. Okay.
and the semi-annually has already been worked. The other one, quarterly two, I had 2,225,
Okay. 2000.
225
Okay.
point 11,
911. Okay.
and the monthly two, I had 2,202.13.
Okay. 911. Okay. Okay. Can someone confirm the first one for us? Just confirm the first one.
I think I had the same answers, just the annually.
I've not solved the annually, but the rest is correct.
The rest is correct, but the annually, I had a different answer.
Okay. What did you get?
2,390.5 line.
2000.
319.5 line.
Okay. Okay. Then if all the rest of all the rest are correct, then let's try the annually together. Annually will be present value is equal to future value over 1 plus r exponent n. Okay. Our future value is 4,500 divided by 1 plus 0.18 exponent n. 4,500, 1.18 to exponent 4. What are you getting?
Yes, I'm wrong.
2,321.05.
Okay. Okay. So the person has given up. Let's come to what we call the effective interest rate. Okay. Okay. Let's take the principal to be
Hello.
2,000. Yes, yeah.
Please go back to the other slide. The quarterly, what figure did he get? I want to be
The
sure.
quarterly, they have gotten
2225.11. 2225.11.
And then the monthly.
The monthly is 2202.13.
Okay, thank you.
But
Yeah.
I'm having issues with getting the number for the years because the annually you are the 4. So if you can help me in that.
The annually we are compounding one time in a year.
Okay.
So if you are doing it 4 years, it means
Because
that the compound will be done 4 years, 4 times.
then the quarterly.
Quarterly means in a year we are compounding 4 times, isn't it?
Yes.
So if you are doing this for 4 years, how many times are we going to do it in the 4 years?
16.
16.
16. Okay, so the exponent will be 16. But just that we will change the rate now to what? Quarterly rate. So as soon as we change the rate to quarterly rate, it means that the exponent must represent quarter. But if the rate is annually, it means that the n must represent a year annually.
So in this case, you divide the rate by 16.
By 4.
By 4, okay.
Yeah, you are giving the rate is annual rate. So if you want to get a quarter rate, you divide by 4.
Okay.
Okay. Yeah.
So if semi-annual, you divide by 2.
You divide by 2 and multiply the exponent by 2.
By
The exponent will be by 2. 4 times 2.
okay.
Which will be 8. So as soon as
Okay.
we change the rate, the exponent must also represent the rate that you are using.
Okay.
Okay. Let's come to effective interest rate.
Sir, I have a question.
Okay.
When we get to where we have the rate, we are multiplying the rate and the exponent. Once you multiply or you do the exponent, what figure are you picking? Should we round it off or you should pick the whole decimal
The
before you
decimal,
divide it by the future value?
no, the what? The interest rate. Are you talking about the interest rate?
Yes,
The
where you
interest
have
rate,
to go and
the
divide.
interest rate
No.
is in percentages. So write it as if it is 5%, we change it to decimal 0.05. Don't write the 5.
Okay,
So
I'm
the
talking about after the converting into the decimal for the percentage. You know the exponent. You also have to do the exponential of the rate.
no, let me get what you are saying. If you are
Okay,
doing
so
quarterly,
let's use the example upwards. The present value 45,000, where you have 1.09 exponent 8.
okay.
So when
Okay, you want to approximate this one, all this.
I'm asking which one is advisable, because I know if you approximate, there will be a difference in the answer. So
No. They will allow for the difference in the answer.
okay, so you don't have any opinion on which one we should use, right?
If you want to, you can approximate this one to 3 decimal places and divide it by this.
Okay.
That's why I'm saying that someone can also choose to have 1.09 exponent 8 times 4,500. Are you okay? So if this one, then you approximate it to 3 decimal places and now use it to multiply this one. Whatever answer that you are going to get will be 2,300 something, but maybe it's this one that was going to change.
Okay.
So it will not be anything. All right. Let's look at this example. Let's say that our interest is, our principal is 2,000. We are paying interest of 10%. And let's assume that this is going to be done, compound is going to be done annually. So it means that the first year, our compound interest will be 10 over 100 times 2,000. That will give us what? 200. Are we okay? Okay. That is annually. Let's come to compounding is done semi-annually. It means that we are going to compound this 2 times before a year, 2 times in a year. So the first one will be, we are doing this semi-annually. So if you like, you can do 10 over 100 times 2,000 times 6 over 12. But just change the rate to semi-annual rate. So 5 over 100 times what? 2,000. That will give us 100. So the second year will be 5 over 100 times 2,100. That'll give us 105. This one, the total interest under this one is what? 205. You can see that the interest rate is different. The interest rate is different. So you can see that it's not a 10% that is used over here. It's a different rate on the 2000 that is giving us a 205. But it is a 10% over here that is giving you that particular side. So what I'm trying to say is that if the interest is compounded annually, the actual interest rate will always be the same as the interest rate attached to the value. The interest rate attached to the value is what we call nominal rate, or some people will call it par rate. So the interest attached to the amount is what we call the nominal rate or the face rate. But the actual interest paid, which is a 205, is what we call the effective interest rate. But the question now is, how do we calculate this effective interest rate? That is the question now. How do we calculate the effective interest rate now? How do we calculate the effective interest rate now? The effective interest rate, we are talking about what interest rate, if we apply it on the 2000, we are going to get 205. What interest rate, if we apply it on 2000, we are going to get 205. How do we calculate that interest rate? It can be calculated as 205 over 2000 times 100. What are we getting? 205 times 2000 times 100. I'm getting 10.25. Is that correct?
Yes.
Okay.
Please.
But we can't be doing this like this. So we have a way of finding the effective interest rate. What we do is that we will just take the nominal rate. If we want to find the amount, we just take the nominal rate and adjust it based on the frequency of how the interest is being paid. So the effective interest rate, which is effective interest rate, effective interest rate. Okay, let me use it like this. It's calculated as 1 plus R over M exponent N minus 1. All of this multiplied by 100. So we just take the interest rate, then we adjust it based on how the compounding is done. So if you want to do this, the effective interest rate can now be calculated as 1 plus, what is the annual interest rate?
10%.
10%, which is 0.1. How often are we compounding? Semi-annually, isn't it?
Yeah.
Okay, exponent what? 2.
True.
Okay, because it will be done semi-annually, so it will be 2. All of this minus 1. Then you multiply your answer by 100. Let's do this. We are going to have 1.05 exponent 2 minus 1. What are we getting?
$0.1025.
So multiply by 100 and see.
Okay. 10.25.
Okay. Which is the same as this one. So this is how we find the effective interest rate. So if the compounding is done monthly, the N will be 12, and this will be divided by 12. Okay. Let's take maybe an illustrative question. We solve one. Then we go to the tutorial questions on compound interest. Okay, let's look at illustrative question under the effective interest rate. So they can ask you to differentiate between effective interest rate and then the nominal rate. The nominal rate is the rate attached to the principal. Is the rate attached to the principal. Is the rate attached to the principal. But the effective interest rate is the actual interest rate paid on the principal. Okay. Oh, Charlie, my breath.
Let's take some 5 minutes break. Yeah.
Okay, that'll be nice. Let's make it 10 so that we come back 10 o'clock. This is 9:50.
Okay.
Yeah.
Please, can you come over with the definition for effective interest
We are
rate?
waiting for you.
Oh, okay.
Please, okay, so please, can you take over, go back and then do the effective again? I think I was not thinking straight.
Okay. Then I will still do the effective for. So you're okay up to this side, the semi where you calculated the interest.
No, I didn't.
Or you're not okay with this side, only this side. Or for the effective interest itself.
The first one you did, no?
Yeah.
It's the same as the last one, the one you just circled.
Yes, the one that I did, this is how you should calculate it if you are able to calculate the interest. But you can't be calculating the interest like that. So the only thing is we use a formula to calculate it, and this is the formula.
Okay.
Okay.
So you just go over the formula again and let me just.
Okay. So the effective interest rate is calculated as 1 plus R over M exponent N minus 1. Then the answer that you get, you multiply by 100. The R is the rate given to you. The M is the number of times that the compounding will be done. So if it is semi-annually, then this will be divided by 2. The N is also the number of times that you are doing it. So if it is semi-annually, this will be 2, or this will be 1 times 2. Okay. If it is quarterly, this will be divided by 4, and this will also be 4. If it is monthly, this will be 12, and this will also be 12. Okay, so let's take some examples. At least let's take one example so that we can do it again. Okay.
Let's take this.
Okay, so under the effective interest rate, we have someone said I should say something about a nominal rate and then the effective interest rate. The nominal rate is the rate attached to the amount, the principal. The rate attached to the principal is the nominal rate. But the actual rate that is paid on the principal is what we call the effective interest rate. That's what we call the effective interest rate. So if the compounding is done annually, the effective interest rate will always be the same as the nominal rate. But if the compounding is done differently, like monthly, semi-annually, and quarterly, then the effective interest will always be different from the nominal rate. Okay. Let's look at the illustrative question. Let's look at the 2. Calculate the effective annual rate of interest of the following bank of the following quote from 2 banks on loan to customers. A, 15% per annum compounded quarterly, bank A. 15% per annum compounded semi-annually, bank B. Advise your company which bank they should borrow from. Let's look at that one. Then we move on to tutorial questions on compound interest. Okay. So let's look at the banks. The first bank, which is the bank A. Bank A, the interest rate is 15%. done quarterly. So it's done quarterly. Bank B, the interest rate is done what? How did they do it? Semi-annually. So semi-annually. So let's find the effective interest rate for all the two banks and advise the company which of them they should borrow from. So effective interest rate, Bank A. Okay, looking at the formula, we are going to have 1 plus, the interest rate is what? The annual interest rate is what? 15, isn't it? 15,
Okay.
or let me make it 0.5. Okay, 0.5 divided by, how are they doing it? Quarterly, isn't it? So divided by 4, exponent 4, because we are doing this for only a year, minus 1. Okay, let's do that. Let's do for Bank A. What are you going to get for Bank A? We are going to have 1 plus 15 divided by 4. Would that be 2.5?
15 divided
0.75.
0.75.
0. 0 point what?
375.
3.75
Okay,
divided by 100.
0.375.
0.0375.
Okay, exponent 4 minus 1. So this will give us 1.0375 exponent 4 minus 1. What are you going to get? Then you multiply this answer by 100. What are we getting? What is the percentage? Then we come to Bank B. Bank B, there will be 1 plus 0.15 over 2 exponent 2. Yes. So 1 plus 0.075 exponent 2 minus 1. 1.075 exponent 2 minus 1 times 100. So what is the interest rate for the first bank?
15.87.
15.87. Okay. The second one is
50.56.
15.56.
56.
So which of the banks should they borrow from?
Bank A.
Are you sure?
Yeah.
Bank A, the interest rate is 15.87.
No,
B,
Bank B.
they should
Bank
borrow
B is a
from.
lot. Yeah.
Okay, they should borrow from Bank B. All right, let's look at tutorial questions. We are going to look at tutorial question 1. Oh, let me see the one that can give us the knowledge about the other one. Okay. Okay, let's look at question 2A first. Question 2A first before we move on to the one. Tutorial question 2A. Joy Mommy. Someone should read for us.
Joy Mami Limited is establish an endowment fund to finance a scholarship scheme to provide funding for the education of children of its employees. The company plans to make an initial deposit of 500,000 into the fund now. The initial deposit will be invested for 3 years before any disbursement will be made from the fund. The effective annual rate of return on the fund is expected to be 14% in the first year, 15% in the second year, and 16.5% in the third year. So, compute the balance of the fund at the end of the 3 years.
Okay. So you can see that this is compounding, but at a different interest rate, isn't it? Okay. So this one I will show you 2 ways of
Yes.
doing it. You can do it differently, or you can just put all of them together and do it. So they are saying that we should calculate the amount at the end of the 3 years. How much are they putting in the bank today? How much are they investing today?
500,000.
500,000. So the present value, question 2A, the present value is 500,000.
500,000.
Okay. They are asking you to find the amounts at the end of the 3rd year. The first year rate is what? The first year, what was the rate for first year?
Fifty, 14%.
Okay. Second year is what?
15.
15. And third year, what is the rate?
16.5.
16.5. Okay. All right. So we can do this separately by finding the amounts at the end of every year. So let's find the amount at the end of the first year separately. So the amount at the end of the first year will be calculated as 1.14 times the initial amount. Are we okay? Is that correct?
Come again.
The amount at the end of the first year will be 1.14 times 500,000.
Okay, yeah.
Okay. That will give us how much?
Five seven 570.
570,000.
570,000. Okay. Let's now come to second year. The second year, the amount will be what? 1.15 times 570,000. Are we correct? Okay.
Six five five 500.
655
655,500.
like this.
Yes.
Okay. Let's come to third year. Third year, we can say that it is 0.165 times 655,500. Are we correct with that one too?
Seven six three six five
7636
58.
58. Okay. So this is the total amount at the end of the what? The third year. This is the amount at the end of the third year. You can do it one by one. Assuming they ask you to do this one for 20 years, and the person is going to do it for 20 years or 6 years. If you see they're doing this thing one by one, will take your time. So someone can decide to say future value at the end of the third year. Someone can say that I can calculate this like this. 500,000 multiplied by 1.14 multiplied by 1.15 multiplied by 1.165. Would the person be correct?
Yes.
Yes. So if the interest rate is different, this is how we do it. Future value is calculated as the present value. Then you have 1 plus R 0 exponent 1 if it is yearly, Then we have multiplied by multiplication, not. So I'll put 1 plus R0, R1, exponent 1, because that will also take 1 year. Then 1 plus R2, exponent 1. So the future value will be calculated as 500,000 into bracket 1.14, 1.15, 1.165. Multiply and see whether you get the same answer. Seven, six,
7636
5,
57.
okay. So that is all. That is the amount that they are asking you to calculate at the end of the third year. All right. Let's look at the first question. Question 1. Question 1. Question 1. Someone to read the question 1 for us.
You are the assistant to the finance manager of Kunta Medical Center. Your boss is negotiating a deal with an investment company investing 500,000 over 3 years. The main terms of the proposed investment deal are that if the amount is deposited now and invested continuously for 3 years, it will attract an 18% annual interest rate with quarterly compounding. However, if the initial deposit of 500,000 is maintained and additional deposits of 50,000 each are made at the beginning of year 2 and year 3, the deposit would attract 18.0% annual interest in year 1, 18.5% in year 2, and 19% in year 3, all with quarterly compounding. Your boss has asked you to do some computation to inform her about the growth of the deposit based on the terms of the proposed deal. Recall, suppose 500,000 is deposited now and there are no top-up deposits in the future. Compute the future value of the deposits at the end of the third year. 2. Suppose the initial deposit of 500,000 is made now and the top-up deposits of 50,000 each are made in the future per the terms of the proposed investment deal. Compute the future value of the initial deposits at the end of the third year. Compute the aggregate future value of the top-up deposits at the end of the third year. Compute the aggregate future value of all the deposits at the end of the third year.
Okay. So they are saying that your company or your boss is negotiating an investment with an investment company to invest what 500,000 over what 3 years. So if you are investing only 500,000, what will be the interest rate on your investment?
18%.
18%. But if you are going by the conditions that they are giving to you, that at the beginning of second year, you should add additional 50,000. And also at the beginning of the third year, you should add the additional 50,000. What will be the interest rate now for the 3 years?
18%.
It will be 18% in the first year, 18.5 in the second year, and 19% in what year 3. If you should go about a proposal that they are giving to you, if you agree to add 50,000 at the beginning of year 2 and also add 50,000 at the beginning of year 3, the interest rate is going to change for each of the years. Are you okay? It means that if you're not willing to pop up the 50,000 as agreed on, you are going to be charged only 80% on your investment. Is that the case?
Yes.
Okay. If you are able to go about the proposal or the conditions that are, then the interest rate will change. But the first one, they are saying that suppose your 500,000 deposit is made now, and there are no top-up deposits in the future, compute the value of the deposit at the end of the third year. So in this case, what will be the interest rate that you will be charged? What interest rate are you going
18%.
80% over the what? The 3 years, isn't it? How is the interest
Yes.
charged? How is the interest charged?
Compounding.
How is the interest charged? Is compounding annually or what?
Okay, so the first part. The main
Quarterly.
Continuously for 3 years.
It was compounded quarterly.
It will attract an interest, an 18% annual interest rate with quarterly what?
Compounded.
Okay, the continuously that they are talking over there is that you will not go and withdraw any amount of money from the investment. So as soon as you put the 500,000 over there, it will be there till the end of the what? The maturity period. That's why they are saying the continuously. All right. So if you are not doing any top-up deposit, you are going to earn interest at what? 18% compounded what? Quarterly. So let's look out to the question 1, which is the A. Okay. This one, the future value will be calculated as, because the interest, the compound will be done differently. It will be the present value 1 plus R over M N times what? M. You write it like this. You first have to quote the formula. They will give you marks for that. Then if you like, you can define your terms. You can define it. But if you don't have time, you can just go straight forward to calculate your future value, which will be 500,000 into bracket 1 plus 18 divided by, let me make it 0.8, 0.18, 0.18 divided by what? Zero 0.18 divided by what?
4.
Divided by 4, okay. What will be the exponent? It will be
4 by 3.
3 times
4 by
4.
2.
That will be 12. So if you are doing quarterly, it means that you are going to be charged interest what? 12 times. So our future value will be equal to 500,000. Okay, 0.18 divided by 4 is what?
0.045.
0.045. So this will be 1.045 exponent what? 12. On your calculator, give me the answer.
I'm getting 847
847
940
940
0.72.
0.72. Okay. All right. So are we okay with the first one? Okay. Let's come to the B part now. How the first one is okay, isn't it? Okay.
Yes.
The B part, they are saying that suppose the initial deposit of 500,000 is made now, and the top-up deposit of 50,000 each are made in the future per the terms of the proposed investment deal. So you can see that each year the interest rate will be different because you are popping in the additional investment as agreed per the what? The terms that we have. Are you okay? So if this happens, it means that in the first year, what will be the interest rate for the first year?
18%.
It will be 18%. So our future value based on the initial 500,000 will be the 500,000 multiplied by 1 point what?
1.8.
1.18. No, okay, let me make it. It will be 18%. Okay, let me do it so that everybody can see. It will be 0.18 divided by what?
It's network. What's up?
Okay. Let me do it so that everybody will see. It will be 1 plus 0.18 divided by what? 4, isn't it?
Yeah.
Exponent
Yes.
what?
Exponent 3.
No. We are doing it the compound is done quarterly. And the interest rate, this interest rate is for only 1 year, isn't it?
Yes.
So how many times can we charge the interest in a year? Quarterly compounding.
Exponent 4.
It's exponent 4. Are we okay with that? Okay. Then second year will come. This is first year. Second year will come. 1 plus, what is the interest rate for the second year?
18.5.
18.5. So it will be 0.185 divided by what? 4. Exponent 4. That is year 2. Then we come to year 3. It will be 1 plus, what is the interest rate for year 3?
19.
It will be 0.19 divided by 4. Exponent what? 4.
4.
That will be for only year 3. And the interest will be compounded 4 times in a year. So exponent 4. This is how we do it. So let's find the future value for only that particular one. If you like, you can put all of them into the calculator and get the answer. What are we getting?
I'm getting 860
860
187
187 860
point
1875
let's say 60.
60. Okay. Okay. So that is the first part of the question that they're asking. They are saying that you should compute the value of the initial deposit at the end of the 3rd year. So this is how the initial deposit will be invested at different interest rates. That is the first one. Then the next one is compute the aggregate future value of the top-up deposit at the end of the 3rd quarter. When are we going to do the first deposit? The first top-up deposit. When are we going to do it?
First year.
No.
The second year.
At the beginning of what? At the beginning of the second year, the first top-up. That is where we are going to do the first top-up, isn't it? The first top-up will be done at the beginning of what? The second year. Read the question again.
Okay, so he said, however, if the initial deposit of 500 is maintained and additional deposits of 50,000 each are made at the beginning of year 2 and 3, the deposit would attract 18% annual interest. Yeah.
Year 1, 18.5.
So we are doing it at the beginning of.
So the first top-up will be at the
year 2
beginning.
and 3.
At the beginning of year 2, that will be the first top-up, isn't it?
Yeah.
And the second top-up will be at the beginning of what?
Year 3.
So the first top-up will be invested for how many years?
1 year.
No, first top-up. at the beginning of second year.
So 2 years.
It will be
The
invested
second
for
year and
2
third
years.
year.
It will be
Yeah.
invested for what? 2 years, isn't it? So let's find the
Yeah.
future value of the first top up. Let's find the future value of the first top up. That would be 50,000 into bracket 1 plus 0.185 because it will attract interest from year 2 over 4 exponent 4 multiplied by 1 plus 0.19 over 4 exponent 4. This will be invested for only 2 years, starting from the second year. So it will start any interest from the second year, which is also compounded what? Quarterly. So the first interest will be year 2, then multiply by the year 3. That will be the amount. Let's find that amount for the first top up. Then we look at the second top up. The second top up will be invested for only a year, isn't it?
Yes.
That will be only year what? 3. So
Year
the
3.
future value of the second top up will be 50,000 into bracket 1 plus 0.19 over 4 exponent what? 4. That's all. That will be invested for only 1 year, which is year 3. Let's get the values, and I will show you how you can also calculate the top up value for all the 2 at once.
So the first one I got 72132.
132.
Yeah, that's all.
Okay.
So,
Is it the second one? Is it the second top up that you're talking about?
no, the first one now.
Okay.
So that one I'm getting 60. The second one. Yes, 60198.56.
60198.56. Okay. So the last question. Okay, let me show how we can also calculate the top up value differently. Okay. Okay. You can also calculate the top up value differently. Let's come here. Let's calculate the top. We can calculate the top up, the future value of the 2 top up at once without doing it separately. Okay. All right. Okay. We know that in the third year, the total amount that we are going to be investing in the third year will be the what? The amount at the end of the second year plus the 50,000, isn't it?
Yeah.
Okay. So if you want to do this, you can have 50,000 into bracket 1 plus 0.185 divided by 4 exponent 4. It means that you are going to invest this one first before you come to the third year. So the third year, what you are going to have will be, so this is the amount at the end of this one plus the amount
Plus.
you're going to have in that particular year, which will now be 50,000 plus 1. 50,000 plus 0.185 exponent 4 plus 50,000 Then all of this multiplied by the third year amount, which is 1 plus 0.19 over 4 exponent what? 4. So in the third year, you reinvest the amount that you have gotten from the second year, which is this one. Then you now add the new top up to it. Then they will now be invested for the third year, which is 1 plus this one. But this is too much for you. So do it separately, one by one. One by one.
Okay.
What is the question saying? The question is saying that we should find the aggregate value. We should compute the aggregate future value of all the deposits at the end of what? The third year. At the end of the third year. So they are saying all the deposits. How do we go about it? All the deposits. What is the amount? What is the amount of the 500,000 at the end of the third year?
860187.
Okay. Assuming we are investing only the 500,000, this is what we are going to get, isn't it?
Yes.
Okay. But we are investing 2 top-ups. What is the value of the top-up, the first top-up at the end of the year?
72,132.
Okay, that is the first 50,000. How many 50,000 do we invest?
3.
No, 2.
2. So if you want to go to the bank, you get the amount for the first 500,000. You get the amount for the first what? Top up, and you also get the amount for the what? For the second top up. So your total value will be this plus this plus this. But before we do that, the question says calculate the aggregate value of all the top up. So that would be future value of the top up will be the first top up plus the second top up, which will be your 72 132 plus the 60 139 198 198.56. That will be the aggregate value of all of the top ups. So you just do it separately and put it together. What are we going to have? Let's have the final one, which is the aggregate value for all. The aggregate value will be the initial deposit amount, the future value of the initial deposit, plus the future value of all the top up.
Hello, sir.
Yeah.
With the first interest, not 18%.
The question says what?
The first interest rate.
No, it's not 18%. The first one is 18.0 annual interest in year 1, 18.5 in year 2, and 19% in year 3, all with quarterly compounding.
Okay, so with the top up, I see the first one.
The top up, the first one will
since
start in second year.
okay.
So the interest that we are going to earn on it will be the 18.5%. It means that the 18% in the year 1, we didn't do top up in year 1, so we can't get any interest in year 1.
Yeah, but you repeated the interest for the 19. I think you repeated it twice.
Which side?
That's what I'm not getting for. If you can go back, the 6198. Because they said that the top up starts from the second year. So the second year is the
No, the top up, we are going to do the top up 2 times.
Mm-hmm.
The top up will be done 2 times. If you read the question, the top up will be done 2 times at the beginning of year 2 and also at the end of what? Year 3. So if you invest the first 50,000 at the beginning of year 2, that will be invested for 2 years and it will earn interest for 2 years, which is the 18.5 and 19%. That is for the first top up. Then in the third year, you are going to do additional 50,000 top up again, which is the second top up, which will only be invested for only 1 year, which is in year 3, and that will get the interest for the year 3. So
That was where I was confused, because they said the top up is up to the end of the 3rd year.
no, read the question again. However, if the initial deposit of 500,000 is maintained, an additional deposit of 50,000 each are made at the beginning of year 2 and year 3. Additional deposit of 50,000 each are made at the beginning of year 2 and year 3. So at the beginning of year 2, you do the first top up. So at the beginning of year 2, how many years is left? You will have 3 years. You are doing first top up at the beginning of year 2. How many years are you going to invest it? The first top up.
I don't get the question. If you can come again.
Okay. However, if the initial deposit of 500,000 is maintained, an additional deposit of 50,000 each are made at the beginning of year 2 and year 3. So the first top up will be done at the beginning of which year?
Year 2.
That will be invested for how many years?
2 years.
At the beginning of year 2. That means you have done only 1 year, and you are going to invest this money for 3 years. So
So it
year
should be left
1
with extra 2 years.
it will be left with 3 years. So you are going to invest the first top up for 2 years. So the first year will be the 18.5%, and the second year will be what? 19%. That's how we have done it for the first top up. Are you okay? Okay.
Yeah.
The second top up will be done at the beginning of what?
Year 3.
And that will be invested for how many years?
1.
And that will earn interest at the what? 19%. That is why second top up is only 19. But the first top up will be for 2 years.
Okay.
Are you okay now?
I get.
Okay.
Yes. Thank you.
All right. So the top up values, the aggregate value of the top ups is the future value of the first top up plus the second top up. Then the aggregate future value of all the deposits, you add the future value for all of them. The future value of the initial 500,000 plus the aggregate value of the top up. That is the aggregate value of all the deposits at the end of the year. Do you have any question? I want to discuss the question 3 with you.
Please, with the aggregate,
Yeah.
I want to know if you can do it this way. The initial investment, so the I.
Okay.
That one plus the II, which is the aggregate of the second and third deposit.
That is no, the I will be for 18%. We assume that we're not doing any deposits.
Okay.
But what is the value of the 500,000 now if we are doing the deposit? So that would be the 860,178.60. So we are not going to use the I. The assumption is that we are not doing any deposits. We are not doing any additional top-up deposits. But the question.
No, I'm not talking about the first one. I'm talking about the the first I, which is the 860.
Okay. Plus all the
plus the. Yes.
Yeah, that is it.
Okay. I'm not talking about the A.
Okay. This can also be calculated like this. You can also, don't worry, since you have gotten the figures already, just add them up. I don't want to bother you with any formula. Okay.
All
right. Let's come to, I want to discuss the question 3 with you, but I won't solve that. Okay. If you understand the first one, you can do that one. All right. Let's come here. Someone should read that.
The question 2B, we didn't do that one. Or
question 2B, no, that is based on seeking fund, which will be next week.
Okay.
An online university is setting up an endowment fund for the financing of scholarship grants. A total of 200 million has been raised through fundraising events. This amount will be invested continuously for 5 years before disbursement will be made from the fund. The trustees of the endowment fund have received a tentative investment strategy from the appointed investment manager. Below is an extract from the tentative investment strategy. The seed fund will be invested in fixed income security and negotiated short-term investment to secure the protection of the principal while earning a stable return over the 5-year gestation period. To achieve this objective, the seed money will be invested as follows: 60% in Government of Ghana 91-day Treasury bill, 40% in 6 months fixed deposit account with top class universal banks in Ghana. Over the 5 years gestation period, the maturity value of each round of investment will be rolled over as they mature.
Okay, so
Being the
let's take that one first. So what is the total amount that they are raising, or what is the total amount that they have raised?
200 million.
200
200
million.
million.
How would this be invested?
Will
5
be
years
invested
continuous.
5 years continuous.
It will be invested for 5 years. But how will the money be invested? How is it going to be invested?
Okay, so the proposed option was to invest 60% in 91-day Treasury bill.
So let's find 60% or 200 million and see what amount will be in treasury bill. Seal bill will be 60%.
So 120.
Times 200. That will be 120, isn't it?
Yes.
Okay. The remaining one will be invested in fixed deposits, which will be 80 million. Am I correct?
That's correct.
Yes.
Okay. 3-month treasury bill. How would the interest be compounded? I'm saying 3 months, 91 days. How many months is that?
3 months.
Quarterly, yeah.
Okay, quarterly. So that one they are telling you that the interest will be compounded what? Quarterly. The 40% will be 6 months fixed deposit. How would the interest be compounded?
Semi-annual.
Semi-annual.
Let's move on.
Okay. Being the only trustee with expertise in finance, your fellow trustees have asked you to do some simulation to inform them about the growth of the fund in the gestation period based on the tentative investment strategy. I suppose the annual nominal interest rate on the Government of Ghana 91-day Treasury bill will be 15.251% in a year. In year 1. Year 2, it will grow to 15.4814 in year 2. Then in year 3, 15.7565. Then in year 4, 15.9478. And in year 5, 16.2146. Compute the terminal value of that component of the investment at the end of the 5th year.
Okay, how do we calculate the amount, the future value of the amount in the treasury bill? How do we calculate it at the end of the 5th year? How are we going to do that?
So because we have mentioned that it will be continuous for 5 years and the treasury bill to also 3 years. Okay, let me think twice.
No, this is similar to what we have done.
So present value, then the 120, then times the rate over
one plus the rate over
the rate over 4.
Raise to the power 4.
For 1 year, that is the first year. Are you okay? Second year too, you do the same thing for each rate exponent 4, like that for 5 times. That's all.
Yeah, with their respective rate.
Yeah, the first question that we solved was November 2021. That was the question that I wrote. I wrote FM November 2021. And the following sitting, that was April. This was the question for April. So you can see that if you're able to solve that question, you can solve this one. It's the same understanding. The interest will be compounded quarterly. So you change the rate to quarterly rate. And if you want to do this one in a year, it means that you are going to compound the interest 4 times. So the exponent should be 4 because you are now using quarterly rates. So the exponent should be 4. That is 1 year. You go to the second year too, the exponent will be 4. You change the rates. That is all. Let's come to the second part.
Suppose the average nominal rate on the fixed deposit will be 16%, 16.5% over the next 5 years. Compute the terminal value of that component of the investment at the end of the 5th year.
This one quite is even simple. How do we do this one? The future value will be calculated as what?
As the PV
Okay.
into bracket 1 plus R.
Mhm.
16.1 plus R divided by 2
Okay.
multiplied by 5 by 2.
Exponent 5 by
Exponent 5 by 2.
okay, which is 10 years. I hope we are okay with that one too. The interest will be compounded semi-annually. So you change the rate to semi-annually rates. Then 5 years, you are going to receive
times.
interest 10 times. So the exponent will be 10. Are you okay? Let's look at the III.
Considering the proposed strategy that the maturity value of each round of investment is rolled over as they mature, explain whether the interest that will accrue on the investment over the entire investment period would effectively be a simple interest.
Would this be a simple interest?
No.
No.
Then you give your reason for not being simple interest. All right. The rest, these are the questions that are directly talking about compound interest. The rest are combination of compound interest and annuity. So Thursday, we look at annuity. Annuity is where you are putting the money there, or you are committing yourself that at the end of every month you are going to put this amount of money there. So the money will be invested in a series. Every year you go and put this amount there. Every year you go and put this amount there. That's what we call annuity. So we look at how we go about annuity. What we have done today is that you go and put the money there and just forget about it and wait for the maturity date. But annuity, you'll be committed that, oh, every month I will bring this amount. Every month I will bring this amount. But for the compound interest, you will just go and put a whole sum there and forget about it. You're not going to do any additional deposit again. That is compound interest, and that's what we have to look at today. Annuity, you will be committed to be putting a certain amount of money there every month or every quarter or every year, and we look at how we go about it. After we are done with the annuity, we look at sinking fund and loan amortization, which are always based on the annuity. And we solved the question 10. That was last sitting. We are going to solve that question after we are done with annuity and sinking fund and low amortization. All right. Thank you all for coming. If you don't have any question, I would like to go out and search for cocoa and drink.
Sir,
Yes.
sir, I have a question.
Okay.
The last question that we saw,
Yes.
that with the 5 years, the quarterly, are we solving it like using the compound interest formula, the one that we just solved?
How do you want to solve it?
I'm asking because you said we will just divide it since it's quarterly. We take the rate and divide it the exponent to make it. That's what I was asking.
So assuming I didn't say anything and you have done time value of money, how are you going to solve it?
And that's how I'm going to solve it.
Okay. Then that is how we are going to solve it.
So please, well, let's say the year one, after I've gotten the number, When I get to year 2, will I bring the same figure that I've gotten, or like I'll do it different for the 5 years?
If you are going to do it like that, it will worry you. Don't do it differently. Just put the 120 there. Then the first year is what? 1 plus the rate. What is the rate? Are you talking about the treasury bill?
Yes.
Mention the rate for me.
The first is 15.2514.
So 0.15215% or something like that, divided by 4, isn't it? Then
Yes.
exponent 4. That is the first year. You bring the second year, 1 plus the second year rate divided by 4, exponent 4. Then you bring the third year rate like that. Are you okay?
Okay.
All right.
Yeah, thank you.
Okay. If you want to do it one by one, you see that will worry you. You have to come and do first year, get the answer before you come and apply the second year on it, get the answer. Then you come. Nah, that will worry you. You are using time. Okay.
Okay.
All right. So any other question? Okay. If there are no other questions, then I will see people on Thursday. We'll continue the time value of money. I'll drop another note on the page that will be on cost of capital. We see maybe 2 meetings, we can finish the cost of capital too. All right. I'll see people on Thursday. Thank you very much. All right.